You are welcome to the Physics Hub as we continue our studies on dynamics. And in today's class, we're going to introduce circular motion. We'll concentrate on uniform circular motion, and this is going to be a 4-part series. So we have part 1 to part 4, and this is the introduction to uniform circular motion. So by the end of this class, we should be able to define uniform circular motion, after which we'll state and explain the properties of an object moving in a uniform circular trajectory. The key phrase here is uniform circular motion. This is the one which is going to govern our discussion. We're going to concentrate on uniform circular motion. Now let's start by defining uniform circular motion. What is circular motion in general? You understand that circular motion is simply the movement of an object following a circular path, a circular trajectory. So we have a circle and we have an object which is revolving along the path with a circular shape. And for this object to revolve, it must have some speed. And because it's circular, it must be separated from the center of the circle by a certain radius. So our object is moving around a circular path, and we say it's observing circular motion. Now, there's some key things we need to understand concerning uniform circular motion. What makes it uniform? Number one, the speed along the path is constant. Its speed on the circular path is constant. The rate of change of distance along the circular path should remain the same. So if it takes 2 seconds to complete a revolution, it must keep taking 2 seconds to complete each and every revolution. And we say that motion is uniform and circular because of the nature of the path. Now, velocity will be changing. This is one question we want to discuss about when we come to properties. I'll throw a question on why is velocity changing when we are saying the speed remains the same. So if the speed around the circular path is 5 meters per second, why is the velocity changing when we are saying the speed is uniform? Speed is not changing. And the object is constantly accelerating. We need to justify and explain why the object is accelerating when the magnitude of the speed is remaining constant. Now, the acceleration has a specific name. It's called centripetal acceleration with a symbol A subscript C. It's called centripetal acceleration, and it's always acting towards the center of the circle. We shall explain why it's always acting towards the center of the circle. Now, let's take a close look into an object that is revolving around a circular path. Now, we have a circular path with center C, and we have an object at point A separated by its radius from the circle R. Now, this object is moving in the clockwise direction around the circle. When it reaches point B, it will still be separated by the same radius R. Therefore, we say it's maintaining the same distance from the center. When it reaches C, it's still separated by the same radius R, since it's uniform circular motion. So the radius of the circle remains the same, even if the position of the object is changing. Now, the key question we want to answer first as we come to describe the properties observed by an object in a circular path is, what keeps the object in a circular path? What keeps the object in a circular path? Now, you will come to know that if there was no force acting towards the center, this object was supposed to fly away. It was supposed to move away. It was supposed to move away from the circular track. So, it maintaining its radius, there should be a force which is always attracting it to the center so that it doesn't move away from the radius. I want you to imagine you have a pendulum and you're swinging it in a horizontal circle. If the string of the pendulum happens to break, you don't expect the pendulum to fly towards the center. It should be flying away from the center. The pendulum bob should be flying away from the center once the string is broken. But it not flying away when the string is intact shows that inside the string there must be a force, there must be tension, which is keeping the string away. So let's try to answer this question. What keeps the object in a uniform circle? So here is our object. You will see that there is a force which is attracting the object towards the center at every point. That's why our object is not flying away. Though it's evident that if the string is broken, it will fly away. That force is called the centripetal force. This is the force responsible for keeping the object in a circular trajectory. Centripetal force with a symbol F subscript C is responsible for keeping the object in a circular trajectory. This is evident from the example I just gave. If you have a pendulum, you're swinging it around in a circular path. If the string is broken, it will fly away. It doesn't come to the center of the circle, it goes away from the center. That shows that there is a force which is making it maintain the track, and that force should be acting towards the center so that it maintains a circular path and it remains in a circular trajectory. Now, this is the velocity of the object. When the string is broken, it flies away. Therefore, there must be a vector called velocity because it has some velocity, but it's maintaining a circular path. If the string is broken, it will leave the circular path and fly away. Therefore, it has a velocity which is going away from the center. So we can safely say in a horizontal circle or in circular motion, there is a velocity that is always perpendicular to the centripetal force. And we know from resolution of vectors that if two vectors are perpendicular to each other, the resultant is somewhere in between them. Now that if the string is broken, it flies away, and there is a force which is keeping it in the place. So we have one vector which is attempting to take the object away from the circular path. We have one vector which is causing it to remain in a circular path. So this is our centripetal force, and this is our velocity. We call it tangential velocity. We'll talk more about it. The resultant should be in between them. So the resultant will remain along the circular path. At any point, the resultant will help the object remain along the circular path. So what really keeps the object in a circular path when the velocity is tangential and away from the circle, and the centripetal force is towards the circle? It is because the centripetal force is perpendicular to the tangential velocity. Hence, the object maintains a circular path. The centripetal force seeking the center and the tangential velocity attempting to take the object away from the circle. They are perpendicular to each other. Hence, their resultant is in between. This is the system which causes it to maintain a circular path, because at any point the velocity and the centripetal force are perpendicular to each other. Hence, it will maintain a resultant somewhere between the velocity and the centripetal force. In an exam situation at A2, if you are to explain what keeps the object in a circular path, you should explain that the centripetal force is responsible because it is perpendicular to the tangential velocity. Hence, the object maintains a circular path. This is a very, very important question at A2 level if you are doing physics A2. Right. What are the properties of an object moving in a circular path? We have explained what keeps it in a circular path, but what are the properties of an object moving in a circular path? Number one, we have seen that since it's uniform, the speed must be constant. The speed around the circle must remain the same, but its velocity will be changing. Why is it that the speed is constant but the velocity is changing? A very important aspect for both IGCSE students and A2 students. Number one, speed is a scalar. Speed is a scalar. Velocity is a vector. So speed is not affected by direction, but velocity is affected by direction. Because when you are dealing with vectors, you are dealing with something that is described by two things: magnitude, which is size, and direction. So when you take a look at the nature of the path being circular, the direction of tangential velocity at A is different compared to the direction of tangential velocity at B, which is different with respect to C and different with respect to D. So we can say the direction of velocity is constantly changing. So though the speed may remain the same, let's say 5 meters per second, the direction is constantly changing. Therefore, velocity is changing. Why? Velocity is fully described by direction and magnitude. So though the magnitude component of velocity is remaining the same, since we're saying speed is constant, the direction component of velocity is changing. Why is it changing? It's the nature of the path. Naturally, that path causes the direction to keep changing. So in an exam situation, if you have to explain why the speed is constant but the velocity is constantly changing, you come to a point of saying, due to the nature of the path, the direction of the object is constantly changing. And since velocity is a vector, it will be constantly changing as direction is changing. At one point, that was the direction of velocity. On the next point, this is the direction of velocity. On the next point, this is the direction of velocity. And this is the direction of the velocity at the other point. Why is this so? Because of the nature of the path. Now that direction has changed, velocity must change. Because velocity, its magnitude and direction. Even though the magnitude may remain the same, the direction has changed. Consequently, velocity has changed. Now, speed being a scalar quantity is not affected by the change in direction, hence it remains constant. So you will find that the magnitude of velocity is 5 meters per second throughout the course. But velocity is changing. Why is it changing? It was 5 meters per second to the east, 5 meters per second to the south, 5 meters per second to the west, 5 meters per second to the north. So the direction has changed, consequently velocity has changed. This is a very, very important aspect when we're explaining why speed remains constant while velocity changes. Now, the object is constantly accelerating towards the center. Why are we saying so? We said the net force is acting towards the center. The centripetal force is acting towards the center. And according to Newton, if there is a net force, there must be some acceleration on an object. So the object is constantly accelerating towards the center. Why? The acceleration must be in the direction of the force. Since the force is towards the center, the acceleration is also towards the center. Newton said F net is equals to ma. Now that we saw that there is a force which is towards the center, which is keeping the object around a circular path, there must be an acceleration in the direction of the force. Which direction? The center. So we also have an acceleration which is called centripetal acceleration. The term centripetal means center seeking. So the centripetal force is this force which is seeking the center of the circular path. The centripetal acceleration is the acceleration due to the centripetal force, and that acceleration is also seeking the center of the path. I will close on this part. We have described the major properties, so I want to leave you with some few questions for practice. Remember, number one, since it's uniform motion, speed along the circular path is uniform. So number one, speed is uniform. Number two, velocity is constantly changing. Velocity is not constant. Why is it not constant? The direction component of velocity is changing due to the nature of the path, hence the velocity is changing. And since there is a force which is towards the center, there must be some acceleration according to Newton's second law. Since there is some force acting towards the center, remember I said this force is responsible for keeping the object in a circular path. There must be an acceleration which is in the same direction as the force which is towards the center. This is, in a nutshell, the properties of an object moving in a circular trajectory. I'll leave you with these three questions for your practice. Try to answer these questions until we meet in the next part 2. Your coach signing out. Chigo.